Ladies and gentlemen, I am the holder of the warmest greeting to all of you from the Educational Technology Group of the Universidad Técnica de Encalada. My name is Sara Cruz and I am glad to submit the communication with title Educational Robotics Forming Scientific Communities in the Classroom. Introduction. In recent years, Ecuadorian professionals have demonstrated interest in scientific production due to the low-level evidence in the university environment. One of the less productive areas in this sense has been computer science, although there is a technical baccalaureate and university degrees in the area. It is necessary to look for alternatives that favor the process of training the scientifics in computational disciplines. The search should start with an emphasis on the approaches made in the previous paragraph. The integral formation of the scientist begins before to access the university. So, within the area of computational science, what educational strategy can be used to initiate the formation of scientific communities in high school in Ecuador? Initiatives that stand out as educational innovation of the area of computer science. The world community has begun to focus greatly on educational robotics in computer science learning. Robots of different types have been widely used as educational resources at the primary, secondary, and higher levels, mainly in teaching and learning process of programming language. The motivation for learning programming language is one of the most worked aspects is classroom with educational robotics, Curto and Moreno 2013. Consequently, favorable learning outcomes are obtained in programming systems. Educational robotics has consolidated in the scientific community of the area of computer science as object of study by the benefits that its didactic use offers. Educational robotics is an environment of learning in which robots are used to favor the understanding of the subjects of study, but it is convenient to establish the difference between teaching robots, TR, and teaching with robots, TWR. These two ways of working with robots in the classroom are represented in figure number 1. In the context of this research, robotics was used as shown in figure number 1, since the main thing was not to learn to build robots, but to work with educational robotics to learn to program computer systems. According to this, the Lego Mainstorm kit was used, specifically the EV3 model. The choice of this kit was due to the review of scientific literature in which it was observed that in various parts of the world, the Lego Mainstorm Educational Robotic Kit is a widely used in primary and secondary education, KIT 2011, and in superior educational, Dana Hill All 2014. This is due to their learning curve. This system hides the complexity of electronic circuits and the students focuses mainly on robot assembly and programming learning. Then, educational robotic kits seem to have found a place in the classroom for system programming and algorithm resolution, which is favorable. Science programming is a key element in the area of computational and relative science. Scientific production in the area of computational science in Latin America. See figure number 2. Ecuador, with just 530 articles, is a clear sign of the poor scientific production in this area, whereas Brazil, the country which produces the most articles, that is 49,296 of published articles. Ecuadorian production is really low, which might occur due to the fact that from the technical baccalaureate until the university careers, the disciplines related to the computational science are visualized just the technical careers. However, all the engineering process management in the educational practice of this area is appropriate for the scientific production. Conformation of scientific communities in the technical baccalaureate. Based on this background, it is considered that one of the elementary subjects in the area of computational science in computer programming. In addition, Ecuadorian high schools have begun to incorporate educational robotics within their learning environments, due to the good results in student academic performance. In the present study, educational robotics was combined with the cycle of the scientific method to see the effect that caused as an Ecuadorian research in the learning achievements of a specific field of informatics. So, the research question which guided this study was recited. What effect does the combination of educational robotics with the scientific method have on learning programming? Objectives of the study. To combine educational robotics, Lego EV3, with scientific method to use them as an educational resource in the teaching of computer programming. Objective 2. To analyze the impact of the educational research Lego EV3 plus scientific method on the learning achievements in programming of computational systems. Hypothesis of the study according to the central research question and the objectives of this study. The following hypotheses were decided. H1. There are significant statistical differences between students who use scientific methodology in their programming classes, Lego E3, with scientific method, and students who do not use it, Lego EV3, without scientific method, with regard to programming knowledge of computer systems before starting the educational intervention. H2. There are significant statistical differences between students who use scientific methodology in their programming classes, Lego EV3 with scientific method, and students who do not use it, Lego EV3 without scientific method, with regards to programming knowledge of computer systems once the educational intervention is completed. Research methodology. Design of the study and participants. The research was quantitative and quasi-experimental design was used with control group. The groups, control and experimental, were made up of students from their high school class of two high schools. Both groups were using Lego EV3 in their school educational robots during programming teaching. The experimental group was incorporated the scientific method to its programming teaching process of the purpose of the present study. The experimental group had 25 students, in the control group had 26 students. In the total sample, 30 men and 21 women are counted, with an average age of 18 years old. In addition, to initiate the study, ethical norms of researching with human beings were taken into account, by which written consent was obtained. Procedure. Within the framework of the involvement project with the community that the Technical University of Machala had, the researchers of the present study carried out the research in two schools of the province of El Oro. In this sense, before the investigation process in both schools, control and experimental, an induction was carried out in which teachers and students were involved. Only the experimental group was trained during induction of scientific method. Students and teachers were then asked to sign a consent and collaboration form. All participants voluntarily expressed their agreement. The study took place during the academic year 2016, from May to September, with the collaboration of the teachers of the subject, before starting classes in the month of April. A standard microcurricular planning was designed for both groups of students. In this way, both control and experimental group received equivalent training. The unique difference was that the experimental group in its planning had the scientific method incorporated. Framework of educational robotics with scientific method. The experimental group's lesson plan design was produced accordingly based of guidelines, which should be followed by students. This ensured the correspondence of the scientific method with educational robots. The details of these guidelines are listed below. Observation and ask question. For the observation stage and question formulation of the research, students were asked to think of what kind of the robot K wanted to design and what challenge would the robot have to face. For this, students were invited to see from videos of Lego EV3 robots already built and in operation. Background research. In this phase, students were asked to review the Lego EV3 robot, manuals for the requirements to assemble the robot they had in mind, and were also told about some selected links of the internet of their search. This theoretical review would guarantee that the robot can be assembled. Hypothesis. According to the selected robot for assembling, students were requested to set challenges for the robot to try to achieve them. This challenge constitutes the research hypothesis experiment. At this stage, the students performed all the tests to see if the robot managed to carry out the challenge. Collecting data. Data from the test carried to the Lego EV3 robot were collected from future analysis. Analyzed data. Students, with the support of both researchers and teachers, placed their data in the SPSS statistical software for further analysis. Conclusions. According to the data analysis performed in SPSS, the student, with the support of both the researchers and the teacher of the subject, made conclusions about the test performed with the robot and the challenge proposed. Report of results. Finally, the stage of the design, construction, and programming of the robot were placed in a scientific poster with the support of the teacher of the subject. During the months that the study lasted, programming classes were done by setting up Lego EV3 robots and programming them. For the month of September 2016, the study ended. The data of official students' scores in the subject in both groups were collected for analysis. Also, as part of the completion of the research project, the high school considered it as an experimental group held a science and technology fair with the robot and scientific poster which were developed during the study. Results. Contrasting hypothesis 1 in table 1 regarding to the pre-test, no statistically significant difference were observed between control and experimental group. This indicated that in both groups, students before starting treatment had the same skills in system programming. In addition, the size of the effect for the difference between the group was relatively small. Consequently, H1 was rejected. Contrasting hypothesis 2. In table 2 regarding to post-test, statistically significant difference were observed between the control and experimental group, in which difference the experimental group had an average range higher than the control group. In addition, the effect size for the difference between groups was relatively moderate. Therefore, H2 was accepted. Conclusions. Conclusion number 1. First of all, the scientific method combined with educational robotic learning environments favors the learning achievements in programming in the area of informatics. In addition, the design, assembly, and programming of robots benefit from the structure of the scientific method, since each phase of the robot's construction and a phase of the scientific method can be selected. This is the key of the lesson plans designed for teaching learning of computer programming in baccalaureate. Conclusion number 2. These findings suggest that scientific method combined with educational robotics is an approximation to the conformation of scientific communities in the area of computational science in secondary schools. Students participate in studies framed in the structure of the scientific method and expose their results through a scientific poster at fairs, in order to start some training with the student as a scientific in the schools, which help setting new challenges in the scientific production of the area of computer science in universities. Conclusion number 3. The quasi-experimental character of this study is a contribution to the educational reality of Ecuador, and it is supposed to be a key piece to go for within the scientific objectives of higher education. In addition, the proposal reflects the need of rise and develop more initiatives on this type in the secondary field, due to the positive collaboration of teachers and students. Conclusion number 4. The linking projects of the university with the communities open a range of possibilities to propose alternatives that favor the formation of scientific communities at the secondary level, specifically in high school baccalaureate, where students are about to choosing their university majoring. The initial formation of the scientific is an approximation is liable for the efforts that are made in the last years of high school.